Hello, my name is Alex Castillo, and today I will be presenting my project for Practicum 1. This project is titled Control Panel for Vivent Transport Units. Now, this project consists on the design, manufacture, and implementation of a new control panel with two drive modules for a Vivent unit for Grupo Canto. Later, I'm going to be explaining what is a control panel and a drive module. Well, but actually, this control panel is designed to allow the operator to activate some different components of the Viben unit. Now, a little bit of context. Minis 2000, also known as Grupo Canto, is a private company that owns a mechanical workshop and also owns 115 buses. Grupo Canto has a partnership with the government, and it is one of the consortiums for the Viben transport system. That means that Grupo Canto borrows their 150 buses for the Viben system. So 115 Viven units are owned by Grupo Canto. Grupo Canto is also the second company that owns more Viven units, just behind ADO, and it is completely responsible for their units. That means that Grupo Canto have to take care of the maintenance, repairing, the drivers, the accidents. So they administrate almost everything about their units. Now, talking about this is going to be more like for the actual project. Every Viven unit of Grupo Canto has a control panel. This control panel allows the operator to activate some components of the bus, such as magnets from the passenger doors, the frontal doors, the back rear doors, lights, exterior front lights, the exterior rear lights, interior frontal lights, interior mid lights, interior rear lights, the horns, the stereo, the USB ports, Wi-Fi, and some other components. So this Torep, this control panel, it's manufactured by an external company. It is not manufactured by the same company that manufactures the actual bus. So there's no problem with modifying the electrical system since the buses already are belong to Grupo Canto. So there's no problem with warranty topics or something like that. Grupo Canto is free to modify their entire units and their electrical systems. Now, these Torep control panels are closed source system. That means that only Torep, which is the company that manufactures this panel, only they have the access to the technical information required to repair or reprogram the control panels. Now, the system also includes two drive modules. The control panel only sends signals received by, sent it by the operator, and the control panel sends that signal or that instruction to a drive module that functions as a power circuit that actually activates some components. There are two drive modules on every unit. One unit or one module controls the front components, and the other one controls the rear components. Now, the problem statement. Now, the problem here is that since the system is a closed source system, and the systems frequently gets damaged by human mistakes, like spilling rings on the surface of the control panel, or accidents that cause short circuits on the electrical system. The control panels, whenever a control panel gets damaged, it must be sent to the supplier, to the Toreb company in this case, for repairing or reprogramming. But the problem is that that company recently left Merida. So since recently left Merida, and the user is not as able to repair the control panel, meaning 2000 that must replace several the damaged control panels, it's obligated to design and build and implement a new own system. The justification of this, as I just said before, is the lack of supplier, the high import cost because every control panel can cost more than 20,000 Mexican pesos. And if they buy another one, it must be sent by other country, no? It must be import, and that means long delivery times. And actually, if even if they buy new equipment, if that equipment gets damaged, we return to the same problem. They are gonna be they will be obligated to buy another one because there's no way or option to repair those damaged controls. That's why the objective of this project is to design and build a lower cost replacement controls that works for the Grupo Cantos buses. Talking about the specifics, objectives is to design, manufacture, and implement a new control circuit that must be later implemented onto a new PCB, designed also by me in this case. And that PCB will be um located on a new case, also 3D modeled by me. And we're gonna also implement two PCBs for the new two driver modules that we are going to design and their cases. We're gonna implement a programming mode. So if whenever a control panel, a panel control panel gets lose their programming, the Grupo Cantos staff can reprogram that control. Now, limitation of this project is that the designed components must fit in the same spaces as the where the original components are installed. Why? Because we cannot leave the control panel exposed because it will be more vulnerable to spilling, drink spilling, or some something that could damage the control panel. So they must fit perfectly on the same space. We are also gonna reuse the wiring harnesses because it will be very complicated to design and do a new wiring harness. The project deliverables will be one new control panel with an LCD screen that sends signals to system modules. It will be reprogrammable and repairable by the Grupo Cantos staff. The new power modules we also deliver two new power modules that are gonna receive the signals from the control panel and activate the different components. We also are going to deliver the schematics of the design systems and the programming code of the design systems. So just clarifying, we are not repairing anything. We are designing an entire new system. The benefits of this is that we are going to have a new local alternative for Grupo Canto. It will be a lower cost. They're going to be, it is a step forward to local technological development. This system will be repairable, will be reprogrammable by the staff, and we also it is also it has also a commercial potential because we could try if this is replicable on other units from other private companies that borrow services to the Viben mobility system. Now, the project requires electrical measurements, 3D modeling, PCB design, system implementation, testing, wiring, and electronic circuit design, and many other communication protocols, many other knowledge. And well, this is the calendar with the activities. It is divided into two projects, if you can say so. One being the control panel that starts from, I mean, it is for this semester. And the second project, if you can say it that way, is the driver models that will be delivered on the second semester of this year. And well, this is pretty much all of my project. Thank you very much for your attention.